The key idea we'll use is that we care about comparing the cumulative hazard at the times where we observe deaths in the population. So let's say we have a population consisting of many patients, which these two patients belong in, and in this population we get to observe the event times or the censoring times. And here we see that a lot of events take place between 20 and 33, so we might expect that in this region we care about comparing the risks of the two patients, which would say that this patient in orange has the higher risk. Let's try to formalize this. So we have here the 4 event times in the data set. Let's assume we have a population of 5 right now, just for simplicity. And of these 5, we have 4 events. And those 4 event times are given by these vertical lines here. At these 4 event times, we see that the orange curve is always higher than the blue curve, so the orange patient always has the greater risk. In general, we can compare the risk of 2 patients or the cumulative hazard of 2 patients by looking at what they evaluate to at the different event times in the data set. So for example, for the first patient, which belongs in group A, we can evaluate the cumulative hazard at 20, 25, 30, and 33 using this orange curve here. And we can do the same using this patient who belongs to group C, and we can get their cumulative hazard at 20, 25, 30, and 33. Notice that we're not using this patient here because we don't observe their event time, we just observe their censoring time. And now that we have these 8 numbers, what we can do is sum up each of these columns to arrive at what's called a mortality score. And the mortality score is a single value that allows us to compare the risks of 2 patients, or rather the cumulative hazard functions, where it matters, which is the event times. And this allows us to say that for patient A, their cumulative hazard is higher than for this patient that belongs in group C, and thus we're able to compare the risks of 2 patients.